Hey guys, so let's look at this review sheet for application of the derivative. So we have values in this table for the second derivative, and we want to say which one has to be true. Now the second derivative does not tell us anything about increasing or decreasing, it only tells us about the concavity. So I'm going to say no at these points. At a local maximum, again, that's more to do with the derivative. A point of inflection is when the concavity changes, and so the second derivative is going to change signs from either positive to negative or negative to positive. At 1, it is equal to 0, but we don't know what's going on immediately to the left and immediately to the right of 1, so we cannot say if it changes at 1 because we don't know what's happening to the left and to the right of 1. But we do know that somewhere on this interval, because the second derivative at 0 is positive, and the second derivative at 7 is second derivative at 2 is negative, that somewhere on this interval, f double prime does change signs. So there is going to be a place where f changes concavity on that interval because our second derivative changes signs. At a point of inflection, two things have to happen. The second derivative has to be equal to 0, and it has to change signs. So if I look at this, I see that 0, 3, and 6 are places where my second derivative is going to be equal to 0, but it's not going to change signs here because of that even exponent. So the only places where my second derivative is going to equal 0 and have a sign change are 3 and 6 because those exponents there are odd. If I have a point of inflection, two things have to happen. The second derivative has to be equal to 0, and it has to change signs. So let's take the first derivative. So we get f prime of x is equal to 12x to the 5th minus 15x to the 4th minus 40x cubed. The second derivative is equal to 60x to the 4th minus 60x cubed minus 120x squared. So when will this equal 0? Well, let's factor out a 60x squared. So I'm left with x squared minus x minus 2 equals 0. This factors into x minus 2 and x plus 1. So I get three possible answers of 0, 2, and negative 1. But same as before, because that exponent there is even, I'm only going to have sign changes of the second derivative at positive 2 and negative 1. X is equal to negative 1 and positive 2 only. Sorry that kind of got cut off there from the next question. The two things that we need to write the equation of a line are a point and a slope. We also want to write the equation of this line at the point of inflection, so when the second derivative is equal to 0. So let's find the second derivative. So if that's f of x, f prime of x is equal to 6x squared minus 12x minus 10. Plus 12x minus 10. The second derivative is equal to 12x plus 12. And at the point of inflection, the second derivative is going to be equal to 0. So when does 12x equal negative 12? When x is equal to negative 1. To find the y value of the point, we want to go back to our function. So f of negative 1 is equal to, negative 1 cubed is negative 1, so we get negative 2, plus 6, plus 10, plus 5. 21 minus 2 is 19. To find the slope, that's the derivative. So I'm going to go back here. So what is f prime of negative 1? 6 minus 12 minus 10 is equal to negative 22 plus 6 is negative 16. I now can write the equation of my line. Y minus 19 is equal to negative 16 times x plus 1. Relative maximum. So we have a relative maximum, and at a relative maximum, f prime changes from positive to negative. So I'm looking for a place where my graph of the derivative, so I'm looking at a graph of the derivative where it goes from above the x-axis to below the x-axis. So here's the place where I go from above the x-axis to below the x-axis. Now I know that on this graph it doesn't look exactly like it is at 4, but that's 4 only. Be careful, they're trying to get you to say -1 and 3. Those are not maximums and minimums because we're looking at a picture of the derivative. Those would be points of inflection, something that we'll look at in a second. If I have a maximum, f prime changes from positive to negative. So let's set up a number line. Here is f prime. It's going to equal 0 at -3, +1, and +2. So -3, +1, +2. That's where my derivative is equal to 0. We now need to know at any other x value what is the derivative. So f prime of 0 is equal to 0 plus 3 squared is a positive number, 0 minus 1 is a negative number, 0 minus 2 is a negative number, so that product is going to be a positive number. So I get a positive number. Now I'm looking for sign changes. -3 comes from this factor, which has an even exponent, no sign change. 1 comes from this factor, which has an odd exponent, sign change. This has an odd exponent, sign change. So where does my derivative go from positive to negative? At 1, because I go from positive to negative. Now I'm not given the derivative, but here it's the same exact concept. So let's find the places where the derivative is equal to 0. So f prime of x is equal to 12x cubed minus 24x squared. I want to know when this is equal to 0. Let's factor out a 12x squared. I'm left with x minus 2 equals 0. So I get 0 and 2. Setting up a number line of my derivative. Here's 0. Here's 2. I know that my derivative is 0 at those points. Let's test the x value at 1. So if I plugged in 1 into the derivative, so f prime at 1 is equal to, that will be a positive number. 1 minus 2 is a negative number. To go on to the right side of 2, that comes from this factor, sign change. Here, no sign change. So relative minimum, where my derivative goes from negative to positive, that is at 2. This seems a little bit more complicated than it is because we have this extra g of x in here. If f prime of x is equal to x plus 2 times x minus 2 times g of x, I know that my derivative is equal to 0 at -2 and +2. Now let's just test any other x value. 0 is always a good one to test. F prime of 0 is equal to a positive number times a negative number times, it says g of x is less than 0, which means it's a negative number. So I get a positive number, so my derivative is positive here. These came from odd degreed exponents, sign change, sign change. Now reading the questions, f has a relative maximum at -2. So that would mean that the derivative changes from positive to negative at -2. That's not true. It changes from negative to positive. So it has a relative minimum at -2. Yep. And a relative maximum at 2. Yep. Changes from positive to negative. When we're talking about increasing and decreasing, we're talking about places where the derivative is positive or negative. And the derivative can only change from positive or negative if it equals 0. So let's find the places where our derivative is equal to 0. So f prime of x is equal to 3x squared plus 12. When is this going to be equal to 0? Well, when does 3x squared equal -12? When does x squared equal -4? No changes, because there's no place where my derivative can change from positive to negative, because there's no place where my derivative is equal to 0. So let's just pick any x value we want. A good x value to pick is 0. F prime of 0 is f prime of 0 is equal to 12. So we get a positive number. That would mean that I'm increasing for all x, because my derivative is always positive. Mean value theorem is the place where the average rate of change is equal to the instantaneous rate of change. So f of 2 minus f of 0 over 2 minus 0. F of 2 is equal to 8 minus 8, which is equal to 0. F of 0 is equal to 0 minus 0, which is equal to 0. So 0 minus 0 over 2 minus 0 is equal to 0. Now let's find the derivative. F prime of x is equal to 3x squared minus 4x. Plug in c. 3c squared minus 4c is equal to 0. Factor out a c. 3c minus 4 is equal to 0. C is equal to 0. And 4/3. But remember that c has to be between that interval. I can't do what we call is like hitting a post. That's not in the interval, it's an endpoint. So the only possible value that I can choose is 4/3. Absolute. That can happen when f prime is equal to 0 or an endpoint. So let's find the places where the derivative is equal to 0. So I get f prime of x is equal to 3x squared minus 6x. This is equal to 0. Let's factor out a 3x. X minus 2. It's equal to 0 at 0 and 2. So the places that I'm concerned about, the x values that I'm concerned about are the endpoints and the places where the derivative is equal to 0. And we're testing the y values because we want to know where the absolute maximum takes place. So f of negative 2. F of negative 2 is equal to negative 8 minus 12 plus 12, which is equal to negative 8. So you, my friend, are negative 8. F of 0 is equal to 0 minus 3 plus 12, which is equal to 12. F of 2 is equal to 8 minus 8 plus 12. You are also equal to 12. And f of 4 is equal to 4 cubed is 64, minus 16 times 3 is 48, plus 12. Oh, goodness. Positive 16 plus 12 is 28. So where does it occur? What x value? It occurs at an x value of 4. The absolute maximum of the function is, so 11 and 12 are very similarly related because one is asking where and the other one is asking what it is. The value of the maximum is 28, and it happens at 4, which was the answer to 11. So whenever you ask for absolute, you got to test the endpoints and the places where the derivative is equal to 0. The reason for that is because I could have something that looks like this. So I've got my absolute here, but I had to test these endpoints, or those places where the derivative is equal to 0. Okay, I know that I went quickly. Great job. Let me know if you have any questions.